So if we're going to write linear equations, there's probably one standard form that you're very used to using. Looks like this, and somebody just said it, right? Yeah? Okay. If I'm moving too fast, please say something. Okay, so we have 2 points here. Can you write the equation of that line?
Yeah.
That's the big question of the day. Okay, so what do you do? Step one. Fred. We calculate that value, huh? What's that? What number should I put in? 1 minus 3. I'll give you mulligan. 3. 2 minus 7. Okay. Y's over the x's, right? And we get negative 1. The do-over without penalty. Next do-over is a penalty. Okay. You're okay with that? Okay. How do I calculate the y-intercept? Who said that? Okay, Levi. How do we calculate the y-intercept? Huh?
I'm lost. You find where intercepts are the axis.
Okay, there's one option here that's really easy, right? It's just there. Okay, so what if this wasn't here and it was, say, right there? Okay, we would plug our slope in, and we would have to find one of these points. I choose the easy one that has a 0 in it and plug it in, right? So 3 is B. And then you write your equation. Okay, you comfortable with that?
Yep.
All right. So this form, very familiar. There's another form that I'm going to show you that's actually easier than that when you have a point and a slope. Okay. So this is slope-intercept. The other one is point-slope form. So if we compare the two. Did Mr. Reimer show this to you?
For a little bit now.
My previous classes didn't see it, so it was always new. Look familiar? That's this is the one I really, really push people to use if they can, because it's easier. You just plug stuff in and you're done.
Yep.
Okay. So slope is -1, right? And then pick a point, doesn't matter which one. Y value, X value. Done. Okay. So point and your slope. Donezo. You could also write y minus 3 equals -1 x minus 0. Perfectly okay. Either one is right. Do you need to put the 0? Probably not. Right. Okay, that's 1.4.
That's it.
Any questions? You might get a scatter plot. Again, pick 2 points, find the slope, y-intercept. It's the same process. Okay, you just get to pick your points. All right. Again, calculus next year, this will pay big dividends. Okay. We don't even use that. People like default to this and like, no, kick you in the face. Use the other one. Okay. I am. I'm a killer. Okay. Parallel lines, what do you know about their slopes? Okay, same slope. Right? There are 3 options here. I'll skip that for now. You'll see this several different ways. Straightforward, yeah? So this is very straightforward because the slopes are the same there. We could also do this. Those are still parallel, same lines. Because these numbers match, right? You can always rewrite it to this form if you want to. Okay. Okay. Let's do a different set. Are those parallel? Okay, so this is where it gets a little bit more fuzzy, right? If this is where a lot of people will just solve for slope-intercept for them, and that's perfectly okay. All right, so if we transfer this, what do we get? We add 2x and divide by 4, right? So it's 1/2 x plus 1/4. Don't forget to divide both of them. Okay. What about the bottom one? Subtract 4x, divide by -8. What's our fraction? They parallel?
Yeah.
Okay. How can I tell from this that they are parallel?
Because they're both like 2 is half of 4 and 4 is half of 8.
Yeah. They're proportional. If you multiply by -2, multiply by -2. Okay, so, and these have to be different. That's key here. Otherwise, they're the same line. Okay, so these must be different. I think we're on track there. So if I give you an equation in some way, shape, or form, write the equation of a line parallel to x minus y equals 1 through, give me a point, 7, 3. Okay, good. Whoa, fall on my butt here. What information do we need?
So x minus y equals 1 and 7 through 7.
Okay, yeah, these are the key pieces here, along with.
And parallel.
So you use your annotation skills in here, it can help, especially in those big long word problems. This one's not so bad, but you get a big long word problem, start circling and not in your book. If you're using a pencil, circle it and erase it. I don't care, that's fine. Like I said, those books are $5 or $10 each, so. Okay, what do we need out of this? What information? Yeah, we need the slope. Anybody? So what are you doing? Talk me through it here, Journey. Excellent plan. So don't forget to leave that. It's negative, so leave it. And then what?
Divide y and negative x plus 1 by negative 1.
Yeah. So you get y equals x minus 1. Right, slope is 1. Oops. Okay. And this is where point slope form can get really beneficial. I don't have to do anything but write my equation now. So y minus what? 3 equals 1 times x minus 7. Done. And hopefully it's not multiple choice and in slope-intercept form, right? But you can manage that. Do I need to show you how to transfer that to slope-intercept form? Do you want me to? Okay, let's do it. I've got a few shaking hands. What's that?
That's a 1. Oh, that's a 1.
It's a 1. The hippity-hoppity property. Remember that? Makes me laugh every time I say it. And then what? Say that? Add 3 to both sides. And you're good to go. Okay. Let's make that a y. Does that help? Good? You confused?
Shouldn't it be a plus 1? Why equals a plus 1? If you're adding 3 to negative 2.
That's a 7.
Oh. I was thinking.
That's why I put the line in there, but apparently the line confused you. Okay. All right, let's move on. We're just not going to address that. Okay. Perpendicular.
Is that the opposite?
Opposite. Opposite. Negative reciprocal. So opposite is not an appropriate term here. So because I can say, well, these are opposite slopes, but they're not perpendicular. Okay, so be careful with your language there.
That's what I meant.
The product of the slopes is -1, right? So if I have a slope of -2, I have to multiply that by 1/2 to get -1, right?
Yeah.
So this is called the opposite, or negative times negative, and then your reciprocal means flip it, right? Because that could be over 1. Do you want me to show you an example of just like the last one? Write an equation of a perpendicular line.
Yeah.
Okay. Write the equation of the line Give me a point.
1, 7.
Why 7? Your favorite number?
7's the universal answer.
No 4 is the positive number.
Never heard of that before, but okay.
Is that 2 over 5?
1 is 3, 3 is 5.
2 over 5x minus 3. I prefer 42. That's getting a little bit ancient for your souls. Huh? What's the slope of that line?
2 over 5?
Yeah, 2 over 5 is the slope. What's our new slope? -5 over 2. You got it. So what's my equation? Not minus 3. We don't know that because this may change it. So what? Remember, my advice, write it in point slope form. Y minus the y value equals the slope times x minus the x value. Now you're done. Okay. So use that to your advantage and makes your life easier. Hallelujah. Most of the stuff, again, you're going to probably run into something that I haven't shown you. Be a thinker, problem solver. It's okay to sit there for a few minutes and look at something and think it through. Okay.
I didn't.
About half review. So just about half of it's new, quote new this year. Sounds like a lot of you know most of it already. So 2 sections, but I'm going to give you the weekend to do it. Tomorrow we're going to talk about how this can apply to shapes and what's called tangent lines. Okay. Not sine, cosine tangent lines, but different kind of tangent lines. Okay. And as always, if you get stuck, I can't answer questions tomorrow if you want to